Okay, picture this. A sudden, brilliant flash splits the sky, and then that deep rumble. We've all seen it. It's beautiful, it's powerful, and honestly, we kind of take it for granted. But here's the thing. Lightning is way more than just a light show. It's this dangerously misunderstood phenomenon, and today we are going to break down its terrifying and, brilliant science.
And I'm not kidding when I say dangerous. The danger is very, very real. Just look at headlines like this one. This isn't some abstract concept. Lightning affects real lives, animals and people all over the globe, every single year. These are real-world events with absolutely deadly consequences.
So just how big of a deal is this deadly force? I mean, to really get a handle on the power we're talking about here, we need to understand the sheer scale of the problem. So what does this number mean? 100. Well, that's roughly how many people are killed by lightning every single year in the United States alone. And that's not even the whole story. On top of that, another 500 people are injured, many with really severe lifelong effects. This is a force that absolutely demands our attention. But listen, the goal here isn't to just scare you. It's about understanding. Because if we can break down the science behind that flash, we can turn that fear into preparation. And to do that, we've got to look inside the storm to see where this all gets started. All right, so let's pull back the curtain on this incredible natural show. The story of a lightning bolt, it doesn't start with the flash. Nope, it starts way before that, high up in the atmosphere, inside a very, very specific kind of cloud.
And here it is. Meet the cumulonimbus cloud. And let me tell you, these are not your average, fluffy, happy little white clouds, no way. These things are colossal towers of moisture and energy. They can stretch up to 15,000 meters high. I mean, that's taller than Mount Everest. This is the engine room of the thunderstorm. This is where lightning is born.
So what's happening inside this monster cloud? Well, at its core, the process is surprisingly simple. You've got these violent currents of rising air. They're called updrafts, and they just smash tiny ice crystals and water droplets into each other. It's basically like rubbing a balloon on your hair, you know? These collisions build up static electricity. Then, the lighter, positive charges get carried up to the top, while the heavier, negative charges sink down to the bottom. And just like that, the cloud is turned into a giant, floating battery in the sky. Okay, so you've got this giant battery just hanging out up there. And like any battery, that stored up energy has to go somewhere, right? It needs to be released. And this happens in basically one of three ways. Lightning can jump from one part of a cloud to another, or even between two different clouds. It can discharge out into the open air, or, and this is the one that's most dangerous to us down here on the surface, it can discharge between the cloud and the ground.
All right, the charge is all built up. Now it's time for the main event, the release. So let's take a closer look at the just mind-boggling power that's packed into a single instantaneous flash.
Okay, get ready for this number. 30,000 degrees Celsius. Let that sink in for a second. That is the almost incomprehensible temperature that the air inside a lightning bolt gets heated to. And it happens in a fraction of a second. It's just a pure explosion of heat energy. Need some perspective on that? For a split second, that little channel of air right here on Earth becomes 5 times hotter than the surface of the sun. I mean, that is a cosmic level of energy. And it's happening right here in our own atmosphere.
Okay, let's bring this back down to Earth a bit. Let's compare that insane power to something we all use every day, a wall outlet. Your outlet at home gives you about 230 volts. A lightning bolt? Try around 10 million volts. And the current? The actual flow of electricity, that's even more dramatic. Your phone charger uses a tiny fraction of an amp. A lightning bolt unleashes a staggering 25,000 amps. The difference in power, it's immense. So, we've got this silent, superheated flash of incredible electrical power. But what about its famous partner? We all know it. If lightning is the electricity we see, then what exactly is the thunder we hear? Well, you could say that thunder is pretty much the voice of lightning. That 30,000-degree heat makes the air around the bolt expand faster than the speed of sound. And when something does that, it creates a powerful shock wave, basically a sonic boom that just ripples outwards. That shock wave? That's what our ears pick up as the crack and the rumble of thunder. So, why do you always see the flash before you hear the boom?
Well, it's just a simple race, and it's not a fair one. Light travels at an incredible 300 million meters per second, so it gets to your eyes almost instantly. Sound, on the other hand, just kind of plods along at a mere 330 meters per second. And that huge speed difference, that's why you can do that old trick of counting the seconds between the flash and the bang to figure out how far away the storm is.
Okay, now this is where our classic image of a lightning strike, one single bolt hitting one spot, gets a little more complicated. The danger is actually way more complex than that. It can spread out in ways you would never expect, and there are 4 main ways lightning can actually injure someone.
First up, you've got the direct strike. This is the one we all picture. It's rare, but it is incredibly deadly. Much more common is something called a side flash. That's when lightning hits a tall object, like a tree, and the current splashes over to a person standing nearby. Then there's a contact strike. This happens if you're touching something, say a metal fence, or even an old-school landline phone when it gets struck. And finally, the most subtle one is called step potential. When lightning hits the ground, the current spreads out like ripples in a pond. If your feet are spread apart, that current can travel up one leg and down the other, creating a deadly circuit right through your body.
Okay, so we've looked at the problem, we've broken down the science, we understand the danger. Now for what is easily the most important part. What can we actually do about it? Let's turn all this knowledge into a practical survival guide for when a storm rolls in.
First off, indoors is always the safest place to be, but there are things you can do to make it even safer. You know those rods on tall buildings? Those are lightning conductors, an invention from way back by Benjamin Franklin, believe it or not, and they channel a strike safely to the ground. For your own home, make sure your electrical system is properly grounded. And when a storm is raging, it's a really good idea to unplug your expensive electronics and disconnect any TV antennas.
Now, being caught outdoors, that's a whole different, much more dangerous ballgame. The absolute key is to make yourself as small a target as possible. So, get out of open fields. Stay far away from tall, isolated things like a single tree or a flagpole. Lightning loves those. Keep your distance from anything metal like a fence. And if you are truly caught out in the open with nowhere to go, crouch down low with your feet touching. This makes you smaller and, really importantly, helps protect you from that dangerous ground current we just discussed.
And here's a really crucial piece of advice, and it busts a common myth. A lot of people think the rubber tires are what protect you in a car during a storm. That's actually not it. A fully enclosed metal vehicle acts like something called a Faraday cage. Basically, it's an enclosure that blocks electric fields. So if lightning strikes the car, the electricity flows right over the metal exterior and safely into the ground, leaving you completely unharmed inside. It's honestly one of the safest places you can be.
And knowing what to do if the absolute worst happens, this can literally save a life. The shock from a lightning strike can stop a person's heart or their breathing, so you have to act fast. An immediate response is critical. First, call for emergency help. Then check for a pulse and breathing. You have to be prepared to perform CPR or give artificial respiration. Your quick action in those first few moments could be the bridge that keeps someone alive until the professionals arrive.
And this next point, this might be the single most important myth we need to bust today. So please listen. People often hesitate to help a lightning victim because they're afraid of getting electrocuted themselves. Let me be perfectly clear. A lightning victim does not store or carry an electrical charge. They are perfectly safe to touch. They are not dangerous. They are in desperate need of immediate first aid. So please do not hesitate to help.
So, I want to leave you with this final thought. We've gone through the danger, we've gone through the science of this incredible natural force, we've learned to respect it, and we've learned how to protect ourselves from it. But all that immense power, 10 million volts, hotter than the sun, it just remains completely untamed. So the next great challenge for humanity isn't just surviving the storm, but maybe, just maybe, one day learning how to harness its brilliant, terrifying power for ourselves. What would that look like?